Good morning again. Here we got ourselves a little topic 2-2. We're going to talk about experimental research methods. Now, within the realm of science, there are a variety of techniques that are used for gathering knowledge. I am very biased. My research, my diploma is in experimental psychology. So clearly I have a bias towards experimental research methods. And as we'll find, it is the experimental research methods are the only one. Remember the four goals of science: to describe, explain, predict, and control. Or even better, the goals of psychology: to describe, explain, predict, and control behavior and mental processes. So it is the experiment that allows us to control, and that's it, the only one that allows for control. And let's just say experimental research methods are the only one that allows us to discover the causal relationships. How about that? Cause. Let's say, for example, you have discovered that A causes B. Huh? And if you've discovered that A causes B, you look at B and say, is B a good thing? Do I like B? If A causes B and I like B, turn on A, right? Turn on A and B happens. If A causes B and B is something you do not like, turn off A. Got it. So we find that it is the experimental methods that allow us to discover the causal laws, and it is these causal laws that allow us to control. Okay? And so there you go, the causal, all right? There you go. Correlational laws that we'll look at as we move along, do not imply causation. Remember the describe, explain, predict, control. Prediction. Correlational laws allows us to predict things, which is potentially valuable in and of itself. You might not have to have the causal laws in order to get your job done, but correlational laws do not allow us to imply causal relationships. Okay? And so we find that some of the key things involved in experimental research is independent and dependent variables. Okay? These are the two most critical ones. We find an independent variable is something that is manipulated by the researcher. You, the researcher, manipulate the independent variable. You measure the dependent variable. The implication is the manipulation of the independent variable causes changes in the dependent variable. Okay? And so that is the fundamental causal relationship. Changes in the independent cause changes in the dependent. Okay? And so we find that the independent variable is sometimes referred to as a predictor, and the dependent variable is sometimes referred to as a criteria. But really, the predictor criteria words, again, you got to remember this particular material comes from an IO site, because I personally would never use the words predictor and criteria in experimental methodology. Though it's a true statement that is, I would reserve those words for correlational methods. I just wouldn't touch those in an experimental setting. But fundamentally, it makes sense: the antecedent, the cause, the effect, etc. But I would never use those words. Right? It just wouldn't show up. Extraneous variables are other variables that are changing, but you did not control them. So let's understand this word control. Okay? In a perfect experiment, what's going to happen is, let's just keep it simple. You're going to have an experimental group and a control group. Okay? So the control group is just the standard, and the experimental group is a new manipulation. So let's say you want to find out if increasing the temperature of the factory will change productivity, something like this. So the control group is put in with 70 degrees, which is what it has been forever. And you're like, I want to see if raising it to 75 degrees might increase productivity. I don't know why. And so some participants are exposed to 70 degrees, they're in the control group. Some are exposed to 75 degrees, they're in the experimental group. And then you're going to measure productivity in some way, and we'll talk about measurement later, but probably things like number of products produced per hour or something. And then you'll check, did the people in the 75-degree experimental group produce more product than the other group, something like that. Well, in this little silly experiment, I have put the experimental group in a 75-degree factory and the control group in a 70-degree factory. But in this experiment, every other condition should be constant. Okay? The lights should be exactly the same for both groups. The noise should be exactly the same for both groups. The type of product should be exactly the same. In other words, every single thing about the environment, everything needs to be identical except 70 versus 75. Okay? Now, of course, this isn't going to, there's always going to be some problems. And that's really what extraneous variables are. Okay? They're things that are changing, but they're not under your control. You're not doing your job properly. Extraneous variables really have the ability for, again, keeping it simple here, extraneous variables have the ability to hide a causal relationship. So even if there is a true causal relationship available, if you have lots of extraneous variables, you will not discover that causal relationship. Okay? That's one way to put it. And so we'll talk a little bit about internal and external validity, but we'll talk more about validity quite a bit more in the measurement little topic today, whatever. Internal and external validity. Internal validity is the extent to which we are doing a clean experiment, essentially. Okay, that an internal validity is the extent to which we can discover the causal laws, or if we have high internal validity, we'll be better able to discover those causal laws. Internal validity refers to, are the results due to the independent variable, as opposed to, the level of lighting was different in addition to the temperature or something. Okay, and so the more control you have, the higher the internal validity. As a rule, experiments that are done in a laboratory have high internal validity. As long as you, the researcher, have done your job, your laboratory experiment should have high internal validity. External validity, on the other hand, refers to essentially, do the results that I've come up with match reality? Something like that, okay? And so what we find is that, say for example, in the study I described a little while ago with the Legos and the leadership, and it's like, in an experiment where you've got college students that are manipulating Legos, does this finding actually reflect how leadership works in a real factory? Something like that. And so we find that laboratory experiments tend to have lower external validity for a lot of reasons, and field studies tend to have field studies tend to have higher external validity. So if you did a study using Legos and college students, you would probably have high internal, low external. If you did a study at an actual factory in a field setting, you would probably have low internal validity, high external validity. Okay, so it's a trade-off, and I mean, it is what it is. Often, good experimental work will first do a study in a laboratory, establish high internal validity, then attempt to replicate the study in a field setting where it is higher external validity. If you get the same results in both a laboratory and a field study, you begin to become confident that your result is true. Control. Now, I kind of basically said this already. In fact, I did not just basically, I exactly said this. So you want to hold constant anything other than your manipulation. I said that. I ain't going to repeat that. Here is the research process. This is sort of like the way science works. I would argue that there's even, formulate a hypothesis. Okay, but the hypothesis, by the way, a hypothesis by definition, a tentative explanation for observations about the relationship between blah, blah, blah. That is kind of the definition of a theory, wasn't it? A theory is a tentative explanation for the observations that I've seen. Okay, observation or theories, we use the deductive method to generate hypotheses from theories. Okay, given a theory, we deduce a hypothesis. A hypothesis is basically, in fact, a hypotheses lead to predictions, right? I don't have the word predictions in there, but imagine hypothesis and between hypothesis and design the study, or maybe between design the study and collect data, but somewhere in there, is predictions. And predictions are a lot like hypotheses, right? An expectation or something like that. But a prediction is highly specific, okay? A hypothesis might be, I believe temperature of factory influences worker productivity. Okay, that might be a hypothesis. A prediction would be, I predict that workers put into a 75-degree factory will produce more products per hour than those placed in a 70-degree. So hypotheses are kind of vaguely worded expectations. Predictions are specific expectations. So we design a study based on this, right? I guess, yeah. Then we collect some data, right? How many products do they produce per hour? We're going to analyze the data using statistics. We'll talk briefly about statistics in this topic somewhere. Finally, report the findings, and the findings will then allow us to go back and formulate hypotheses. It's kind of a strange little image here, but the idea is the research process is not an end in and of itself. The end of the process is, in fact, the beginning of the process. There you go. The end is the beginning. It never ends. Okay. Couple of things, I guess I've already mentioned some of this stuff, but research designs. In the experimental method, there is one thing that is incredibly important. I mean, we've already talked about the second one, manipulation. I, the experimenter, manipulate the independent variable, and I control every other aspect. So I've already said that part, but this random assignment is a big deal. If you don't have random assignment, you don't have an experiment. That's just how it is. If you might look like you have an experiment, but if you haven't done random assignment, you haven't. Random assignment, to put it into a simple perspective, is the ability to take every person's name, put it in a hat, shake the names up, and go, you're in the experimental group, you're in the control group. You're in the experimental group, you're in the control group. If you cannot do this random assignment, you do not have an experiment, and therefore you cannot establish causal laws, right? The causal laws are lost to you. So this random assignment is critical. So let me explain a situation down here like quasi-experiments where it might look like I want to find out if males and females produce more products per hour. I don't know, some silly thing, right? Well, you cannot randomly assign people to be male and female. They are what they are. Now, don't get me wrong, such a study is perfectly legitimate. It's a quasi-experiment. It's perfectly legitimate. You can discover interesting things. Remember the 4 things in science: describe, explain, predict, control. You can do 3 out of the 4 you can't control with a quasi-experiment, but you can do the other 3, and that's 3 out of 4 ain't bad. I believe Meatloaf used to say that. So 3 out of 4 ain't bad. And so it is what it is, but it ain't causal laws. Okay? And then we'll talk research methods in the next part. What the hell? Yeah, I enjoy that. 2 different ways to say the exact same thing. Redundant if nothing else. Blah, blah, blah. Yeah, laboratory experiments, as we said, tend to be lower in external validity. And the main reason they tend to be lower is because when people come into a laboratory study, they look around themselves and they say, I wonder what they want me to do. Now, our goal in science is to discover, our goal in psychology as a science is to discover real, true behavior. But when people know they're being watched, think the Hawthorne studies in the first topic there, when people know they're being watched, they just act differently than if they're not being watched. And so this is a fundamental reason why laboratory experiments are somewhat. I love lab experiments. My bread and butter is a laboratory experiment. But they do have this limitation. And so, look at that. I said it already. Okay, so I'm going to stop there. Look at that. 12 minutes, 14 minutes, good enough. And we'll talk about observational methods in the next video.